Friends, once again welcome to another lesson from iCampSA. In today's lesson we're gonna be doing functions, okay, and then the area of focus is the tangent function. Without wasting any more time, let's get into it. Okay, so we have the basic tangent function. As you see here, it's represented by this formula: y is equal to tan theta, and this is what we call the simplest form of the tangent function. Okay, and then we can do multiple things in this function. As you know that with functions we can shift them horizontally or vertically, and we can also stretch them. So the same thing can be done for the tangent function, or for all trigonometric functions, in general. Okay, and then once we have done those, we can now use the general formula that allows us to represent the multiple transformations that we make to the function, and that general formula is y is equal to a tan theta plus q. That a there, of which is the coefficient of tan theta. It represents the vertical stretch for the function. It represents the vertical stretch. By vertical stretch we mean how far the function is stretched from the x-axis or from the theta axis, since we're dealing with trigonometric functions. And then plus q. That q, it represents what? The vertical shift. The vertical shift. So it's the shifting of the function up and down. And another thing about the value of a there, the value of a, so a negative sign of a means that the function has been now reflected about the x-axis. A negative sign of a means the function has been reflected about the x-axis. So if the original function started from 0 and went above the x-axis, or went to the positive y-axis, once it has been reflected, now you will see that the function, okay, maybe let me just go a quick sketch to illustrate what I'm talking about. If the original tan function was like this, it went above like that, once we have a negative value of a, you will see now the new function, or the transform function, will look like that, because it has been reflected about the x-axis. That is what is meant by that. Okay, and then so you are already familiar with that. Let's go ahead and get into actually sketching the basic tangent function. Okay, so in order to sketch the function, we do have the table there. We have to fill in the table, and then here this is our y versus theta axis. Okay, so we go to our calculator. Let's complete the table. You make sure that in your calculator you set your calculator to degrees to find the corresponding y value. That is that small d that you will see there on the top of your screen. Okay, and then you simply punch tan 0 degrees, gives us 0. And then we go to tan 45, and it's always advisable to at least use the what you call this thing, the 45 degrees intervals, when you are making your table or finding your values, because you will see that when we get into some of the values, we will not have an outcome. So for tan 45 we have 1, and then for tan 90 we have an error. It gives us an error. So it means that this tangent function doesn't exist at that 90 degrees. At that 90 degrees value, it doesn't exist. So if our function doesn't exist at one particular value, what do we call that value? It is an asymptote. If you are familiar with asymptote, we have an asymptote. And you said the asymptote is that value that the function will approach but never touches. So we have the asymptote. The first asymptote at 90. Let's go to tan 135. We have -1. And then let's go to tan 180. tan 180 we have 0, and tan 225, tan 225 we have 1, tan 270, tan 270 we have once again we get an error. That means that is our second asymptote. It's another value that the tangent function will approach but never touches. We get an error for tan 270, and then let's go ahead and do tan 315, tan 315 degrees. We get a -1, and tan 360 degrees we get a0. Okay, and then let's now go ahead and plot our function and start by calibrating our axis. We're gonna say it's 1 there. I have 1, -1, we have 0 here, then we're gonna have 45, 90, 135, 45, 90, 135, 180, 225, 270, 315, 360. Okay, let's quickly write that. It's 45 degrees, 90 degrees, 135, 180 degrees, 225, 270 degrees, 315 degrees, and 360 degrees. Okay, and that is our Cartesian plane. First thing first, I start by putting lines to where we have the asymptote. That is our asymptote at 90 degrees, and then at what? At 270 degrees. At 270 degrees. That is our second asymptote there. Okay, then let's plot our point at 0. Theta 0 degrees, we have 0. At 45 we have 1. At 45 we have 1. Then at 90 asymptotes, at 135 we have -1. 180 we have 0, and then at 225 we have 1. At 315 we have a -1. 360 we have a 0. And then once we are here, I think let's change here the way we calibrate the function. We're gonna have 1 here and 2, therefore our point will be here, and this one will be here. And then let's also change this one, -1, -2, so that the shape can come out really nice. Okay, 315 and -1. Okay, let's join our points. That's the first branch of the function, and then second branch of the function, third branch of the function. And this is how the tangent function looks like. Okay, so just a few things to note about this function is that remember on the sine and cosine function we said it takes 360 degrees for one cycle to be complete. On the tangent function it's quite different, and it's actually half of that. It takes now what? It takes 180 degrees for the function to repeat itself. So the period of the tangent function is 180 degrees. So if you would come here from 90 to what? To 270, that is a complete cycle. This is actually a complete cycle. If we were to add more degrees here, we will see that this function will continue like this and have an asymptote somewhere there. So it takes from 90 to 270. If you say 270 minus 90, that gives you 180 degrees. So one cycle of a tangent function is completed in what? In 180 degrees. So the period for a tangent function is what? Is 180 degrees. Okay, let's get into some basic characteristics of the tangent function. So the function, first thing first, it has no minimum value. And then it also has no maximum value. As you can see here, that the function, even though it approaches the asymptote, it is still going up, so as you can see with the points there, with the arrows it's facing up, that the function would continuously going up, and at the same time when this side it would continuously go down. So the function has no minimum value and it has no maximum value. Therefore, the range of the function, if we look at the y-axis, what will be the range if we don't have a minimum value and the maximum value? The range, we're gonna say y is the element of from negative infinity to positive infinity. That will be the range. And another thing is that the tangent function, it has no amplitude. Since it goes from negative infinity to positive infinity, so it has no amplitude. Okay, it has no amplitude. And then the period for the tangent function, we said the period, what is the period, is 180 degrees. The period is 180 degrees. Okay, let's say the period is gonna say P is equal to 180 degrees. Okay, and then what else? The asymptotes the asymptotes of the functions will be at what? The asymptotes of the function will be at x is equal to x, or theta, let's use theta, is equal to 90 degrees plus k multiplied by 180 degrees. Okay, that will be the equation of the asymptote. This is the equation of the asymptote, where k represents integer values. So for instance, the first asymptote will be at what? Will be at theta is equal to 90 degrees plus 0 multiplied by 180 degrees, of which means it would be at theta is equal to 90 degrees. This is that first asymptote that we had there. And then the second asymptote will be at what? The second asymptote will be at theta is equal to 90 degrees plus 1 multiplied by 180 degrees, of which would be theta is equal to 270 degrees. And that is that second asymptote that we have there, that we have here at 270 degrees. And then let's quickly calculate the third asymptote. The third asymptote will be at theta is equal to 90 degrees plus 2 multiplied by 180 degrees. Therefore, the third asymptote will be at 60 plus 90, it's 450. Yes, it will be at 450 degrees. That will be the third asymptote. So here, what you have is the equation of the asymptote. That's the equation of the asymptote. So those are the basic characteristics of the tangent function. Let's do an example to see how, just to get familiar with how these functions look. Okay, so for this one, on the same set of axes, sketch the following graphs for the interval of x is the element of 0 degrees to 360 degrees. So just for one revolution. Okay, and then write down the period of each graph. Okay, so we don't have a minimum value, we don't have an amplitude, hence why they asked the period. Okay, let's come here. Let's come here, take our table, copy. We are sketching, we have two functions. Yeah, something like that. Okay, and this is x. This is x now, and here I'm supposed to use x, just easier than theta. Okay. So before we even get to tabling down the values, just a few things. We have a coefficient of tan there. What does it tell us? Which is minus 2 tan x. If we have a negative coefficient of tan there, or negative value of a, which is what I mean, it means that this function has been reflected. And then we have that plus 1. What does that do to the function? It shifts the function up and down. So that means this function has been reflected about the x-axis, and it has been shifted 1 unit upwards. And then we come here, this one is just has a positive value of 3 as the coefficient of tan x, which is the value of a. It tells us that this one has been stretched from the x-axis by a factor of what? By a factor of 3. That is what that coefficient means there. It's not an amplitude. Okay, so let's find the corresponding values. So first thing first, we have y is equal to negative 2 tan x plus 1, and then we have y is equal to 3 tan x. Y is equal to 3 tan x. Okay, and then yes, let's find the corresponding y values. Negative 2 tan 0 plus 1, we get 1, and then we have negative 2 tan 45, we get negative 1. 90, we get an error. Asymptote 135, we get a3, sorry, and then 180, we get a 1. 225, we get a negative 1. 270, it's an error again. That is an asymptote. 315, we get a 3. 360, we get a 1. Okay, let's find the corresponding values for the other function of 3 tan x. At 0, we get a 0. At 45, we have a 3. At 90, we have a error. At 135, we get a negative 3. At 180, we get a 0. At 225, we get a 3. 270 is an error. At 315, we get a negative 3. At 360, we get a 0. Okay, now that we have those points that we have there, we can go to our Cartesian plane. Let's take this one here. I think it's gonna be fine. Just take this one, copy here. A little bit lower. Okay, here we have y versus x. Oh, didn't have to actually remove the asymptotes because the asymptotes are still the same. Let me just extend this one, and then we add more values. I'm gonna have 3, 4, here 1, 3, 4, 5, -3, -4, -5. And then extend our asymptotes. Okay, let's start with the first one. Let's plot the points. Just gonna use 3, where x is 0 degrees, y is 1. At 45, y is -1, y is -1, and then at 90 is error. At 135 we have 3, 135 we have 3. At 180 we have 1. 225 we have -1, we have -1. 270 is an error. At 315 we have 3. At 360 we have at 360 we have, what is this, 1. We have 1. Yes, we have 1. Yeah, okay, and then from there, what do? We join the points. We join the points. We join the points. Yes, and that is how our function is gonna look. And the baseline for this function is at 1. That is not the asymptote, just past the baseline of the function is at 1. Okay, and then let's go ahead and do the other one of 3 tan x. At 0 degrees we have 0. At 45 we have 3. At 135 we have -3. At 180 we have 0. At 225 we have 3. At 315 we have -3. At 360 we have a 0. Then from there we simply join the points. Let's see, sometimes it looks like a straight line now. A1. What are we gonna do with this one? It looks like a straight line. That's the thing about sketching these functions on the same set of axes. But it's not a straight line, it's a curve. It would have been better if we had sketched these functions on a different set of axes, but it's okay. Let's try to how do we make a curve here? Because these functions, I'll just it will be a function of that nature. Yes, that will be the function. That will be the function of y is equal to 3 tan x. It's a curve, not a straight line. It's a curve, not a straight line. And that is how it will come up. Just a few things. You see that with the second function, the blue one, it hasn't been shifted. So the baseline is still there at 0. The baseline is still at 0. And then it also hasn't been reflected, so hence why it starts from 0, go to the positive side. Meanwhile, with the other function, it starts from -1 and goes down, so it has been reflected about the x-axis. So next we are asked to write down the period for each of the graph. So the period for b, so both of these function, the period is just gonna be 180 degrees. Period is equal to 180 degrees because for both of them it takes 180 degrees for each function to complete each cycle. Okay. To complete each cycle. Okay, then next let's do example number 5. So for example number 5, in the diagram below, the graphs of y is equal to f at x is equal to a cos x plus q. It's a cosine function. You can already see that this is the cosine function because of the shape. And then we have the graph of y is equal to m sine x plus n. The sine function is this one here. That's the sine function as shown for the domain of x is the element of 0 to 360 degrees. Write down the amplitude and range of f. Amplitude and range of f. So the cosine function, so we can see that for the cosine function, the maximum value is what? Is 2. The maximum value is 2 and the minimum value is what? Is 0. The maximum value is 2 and the minimum value is 0. So remember the formula for amplitude. Number 1, we said amplitude is equal to 1/2 max minus minimum value. Let's calculate the amplitude. So we said the maximum value is what? 1/2 is equal to 2 minus what's the minimum value? Is 0. Minimum value, therefore the amplitude is gonna be 1. It is gonna be 1. First thing first. And the range of f, the cosine function again, the range of f. So if the minimum value is 0 and the maximum value is 2, what is the range then? So the range is gonna be y is the element from 0 to 2. It ranges between the minimum and the maximum value. Okay, and then next we have to write the amplitude and the range of g. That is our number 2, the amplitude and the range of g. So for the amplitude, let's use the formula of 1/2 maximum value minus minimum value. Maximum minus minimum value. Okay, what is the minimum value? The minimum value here is -2, and the maximum value there is what? Is +2. Is +2. So the amplitude is gonna be 1/2 into maximum value +2 minus -2, close bracket, is gonna be 1/2 into 2 plus 2, which is 4, is gonna be a +2. It's gonna be a +2. And then that is the amplitude. And then for the range, what is the range? Range is gonna be, we use the maximum and the minimum value. Why is the element from what is the minimum value? -2 to +2. Use square brackets because those values are also included. Okay, so that is that for number 1 and 2. So next we're asked to determine the values of A and Q, and Q being the shift, Q being the vertical shift of the function. Okay, so I will show you another formula for calculating the vertical shift, but first thing first, what I want us to do, there are two methods for calculating the vertical shift, just like the amplitude, but we'll start by using the coordinates. So values of A and Q. So we know that this function of f has coordinates here which are 180 degrees and what, and 0, and we have these coordinates here which are 360 degrees and 2. So we can substitute those in order to solve for what? To solve for A and Q. That is the first method we're gonna use, and then the second one we'll use the formulas for the amplitude and the formula for a page. Then for the second one, we're gonna use, here's the formulas for amplitude and the vertical shift. This is our number 3. So we have y is equal to, or f at x is equal to a cos x plus q. y is equal to a cos x plus q. That's the first function of f that we're dealing with. And we know we have two coordinates that we know about the function. In fact, we have 3, because also this one there, which is 0 and 2. But let's just use 180 degrees and 0 and 360 degrees and 2. So we have two coordinates, 180 degrees and 0, and then the second one is 360 degrees and 2. We are solving for what? We are looking for A and Q. So we substitute the coordinates. In order to form our formula. We have two unknowns, so we're gonna substitute. Let's start with the first coordinate of 180. We know where x is 180 degrees, y is what? Y is 0. It's equal to a cos 180 degrees plus q. What is cos 180 degrees? Is -1. Therefore 0 is equal to a multiplied by -1 plus q. Let's take a to the other side. Therefore q is equal to a. That is equation 1. And then for equation 2, let's substitute 360 degrees and 2. Where y is 2, x is 360 degrees plus q. Okay, what is cos of 360 degrees is 1. Cos of 360 degrees is 1. Therefore, we're going to have 2 is equal to a into 1 plus q. Let's make q the subject again. Q is equal to 2 minus a, and that is our equation 2. And then what do? We substitute equation 1 into 2. Since we are solving for these equations simultaneously, we're gonna have q is equal to 2 minus a. What is our a? A is also equal to q. Therefore, we're gonna have take the q to the other side. 2q is equal to 2. We divide by 2 on both sides. Q is equal to 2 divided by 2 is 1. But also, once again, q is equal to what? Q is equal to a. So if q is equal to a, that means also a is equal to 1. And just like that, we have solved for a and q. Okay, that's the first method. The other one we could have used is the amplitude. Okay, so you have to be a little bit careful with this one. The graph is facing up, so the amplitude is positive. Sorry, not the amplitude, but the coefficient, the value of a is positive because the graph has not been reflected. So we already calculated the amplitude. We know it's 1, and that is our a. So a, we could have just read it from here. That is our a. Okay, and then for q, this is the formula I was referring to. For q, you could have said calculated q using this formula, which is 1 over 2 into maximum value plus minimum value. What is our maximum value? It's 2. 1 over 2 into 2 plus what is our minimum value is 0. This is equal to 1 over 2 into 2 is gonna be 1. So you could have used that formula for q. That is the formula for vertical shift. So now you have the formula to calculate the amplitude and the one for vertical shift formula. So a vertical shift formula. Okay, now let's go ahead and determine so we are here, the values of m and n. Okay, so we can use the amplitude. We already know that the amplitude of which is the value of what? Of m here is 2. But the function start by going to the negative side. It has been reflected about the x-axis, so we have to go with -2. If we use that if we use the amplitude, and then we can calculate the vertical shift of which is n, and we can see from the graph that the function has not been shifted, so the value of n is gonna be 0. But let's say you forget to do that. Let's use the coordinate to calculate the values of m and n. We'll use the coordinates, just in case you forget that. You can just read these values from the graph. Okay, so this is number 4. We are looking at what? At y is equal to m sin x plus n. Y is equal to m sin x plus n, and we have two coordinates, which is the function passes through 90 degrees and -2 and 180 degrees and 0. So we have 90 degrees and 2, and we have 180 degrees and 0. 180 degrees and 0. Okay. So we have to substitute so that we can formulate our equations that we will solve for simultaneously, where y is equal to 2, x is equal to 90 degrees plus n. What is sine 90? Sine 90 degrees is 1. So we're going to have 2 is equal to m into 1 plus n. Let's make n the subject. Therefore, n is equal to 2 minus m. And this is our equation 1. This is our equation 1. Let's do equation 2 by substituting 180 degrees and 0. 180 degrees and 0. So where y is 0 equal to m sine x is 180 degrees plus n. Okay, what is sine 180? It's 0. Sine 180 is 0. Therefore, 0 is equal to m into 0 plus n. Therefore, we now have n. N is equal to 0. Therefore, n is equal to 0. So we have already solved for n. And remember, as I told you, that the function has not been shifted because n represents the vertical shift. So if you can see that the function has not been shifted, it makes sense for n to be 0. And then if n is 0, let's come here and solve then for m. So we're going to have 0 is equal to 2 minus m. 2 minus m. 2 minus m. Therefore, we're going to have what is this? It's going to be -2 is equal to -2 is equal to 90 and 2. Oh shit, I see that I made a mistake. The coordinates are what? The coordinates are 90 and -2, and I substituted 90 and 2. I can see from the answer I'm getting that I made a mistake somewhere, so it doesn't change much though. It's 90 and -2, -2, -2. Therefore, we're gonna have, let's come here. This was supposed to be n is equal to -2 minus m. Okay, so when we substitute 0, we're gonna have -2 minus m. Therefore, m is equal to -2. M is equal to -2. That is the answer. M is equal to -2. And it makes sense because the function has been reflected about the x-axis, as you can see here, and the amplitude was 2. So that is that for example number 5. Let's go ahead and do example number 6. So for example number 6, in the diagram below, the graphs of y is equal to f at x is equal to a sin x plus q, a sin x plus q, and y is equal to g at x, m cos x plus n are shown for the domain of x is the element of 0 to 360 degrees. 0 to 360 degrees. Okay, so from the shapes that we see of the graphs, we can see that this one is the cosine function and it is facing down, which means it has been reflected. So the value of m is going to be negative, and then once again it has also been shifted. It has been shifted up, so yes, we're gonna have a positive value of n, I would like to believe. And then next we have this sinusoidal function, and it also has been reflected, it has been reflected or flipped, so, and shifted. Okay, so for number one, let's get into it. Write down the range, amplitude, and period of f. What is f? Is the sinusoidal function. What's the minimum value? It's -3. Maximum value occurs there at 270 is what? Is -1. That's the maximum value. It's -1. Okay, so yeah, the maximum value will be there at -1. So for number one, the range is gonna be, y is the element from -3 to -1. Okay, that's the range. And then next, the amplitude we say the amplitude, we gonna use the formula of which is 1/2 open bracket maximum value minus minimum value. What will this give us? This is gonna be 1/2 into what is the maximum value is -1 minus the minimum value, which is -3. So the amplitude is gonna be 1/2 into -1 plus 3, which is 2, is gonna be 1. E is gonna be 1. And then next is the period. What is the period for the sine and the cosine function in grade 10? The period is always gonna be, or most of the time it is gonna be, period is equal to 360 degrees. But also just by looking at the sketches that we have here, you can see that the period, it takes 360 degrees for the function to complete one cycle. Okay, so that is that for number one. Let's go to number two. Number two, we are asked to write down the range of the function. Gonna say y is the element, what's the minimum value? -1. Maximum value is +3. So the range, the function goes from -1 to +3 to +3. And then the amplitude is next. Amplitude, we use the formula 1/2 into maximum value minus minimum value. This is gonna be 1/2 into 3 minus -1. The amplitude is gonna be 2. Punch that in your calculator, you should get 2. And then the period, what is the period of this function? The period is equal to 360 degrees. 360 degrees. That is the period of the function of g. Remember about the amplitude. The amplitude tells us how far is the function stretched from the baseline. This is the baseline of this function. And as we can see, that is when we go from -2 to -3, it's just 1 unit. When we go from -2 to -1, it's just 1 unit. And here is the baseline of the cosine function there at +1. From +1 to 3 is what? Is 2 units. of which is our function. That is what the amplitude actually tells us. How far is the function stretched from the baseline? Okay, then next we have to determine the values of m and n. That is 3. Number 3, values of a and q. Let me add a page for this. Add a page. We're gonna need one here, and we're gonna need one there. Okay, so for number 3, let's start. We start with a and q is the sine function. For the sine function, we know that it's y is equal to a sine x plus q. Y is equal to a sine x plus q. And then what are the coordinates? The coordinate that we have there that we have to use to solve for a and q. We're just gonna use this method for now. 90 degrees and -3. We can use the what you call this thing, the amplitude and q part. I think what they want you to learn, is solving for this a and q using this method, instead of that shortcut of using the amplitude and the formula for the vertical stretch. It's just good to know them, but let's stick to this method for now. 90 degrees and -3, and we have the other coordinates, which is 360 degrees and -2. So 2 coordinates, 90 degrees and -2. The other one is 360 degrees. Sorry, this one is -3, and this is -2. Double check. Yes. Let's substitute. We start with the first coordinates. We substitute the first coordinates. -3 is equal to a sine 90 degrees plus q. What is sine 90 degrees? Is 1. So we're going to have -3 is equal to a into 1 plus q. Let's make q the subject. Therefore, q is equal to -3 minus a. That is our equation 1. That is our equation 1. Let's do equation number 2 by substituting 360 degrees and -2. -2 is equal to a into sine 360 degrees plus q. What is sine 360 degrees? That is 0. That is 0. So -2 is equal to a into 0 plus q. Therefore, q is equal to -2. Q is equal to -2. Already solved for q. And then we can solve for a. Then we can solve for a. Here, -2 is equal to -3 minus a. We take the -3 to the other side. A is going to be 3 minus 2, which is 1. 3 minus 2, which is 1. Let me double check something quick. -2. Oh, it's going to be -1. Let's do the steps properly. -a is going to be -2 plus 3, of which is -a is equal to -a is equal to 1. Therefore, a is equal to -1. And that is your answer for a and q. Next, we're looking for m and n. M and n. Again, we have 2 coordinates, 180 and 3, and then we have 360 and -1 for the cosine function. We're looking for m and n. So for m and n, this is our number 4. Number 4, y is equal to m cos x plus n. The coordinate that we have there is what? 180 degrees and 3. 180 degrees and 3. And then the other one is 360 degrees and -1. Double check. Yes. Okay, we substitute the coordinates and then we solve. So where x is 180 degrees, y is 3, equal to m cos of 180 degrees plus n. Okay, what is cos 180 degrees? That is -1. So we're going to have 3 is equal to m into -1 plus n. Let's make n the subject. Therefore, n is equal to 3 plus m. We take the m to the other side. This is our equation 1. Equation 1. Let's find equation 2 by substituting 360 degrees and -1. So it's going to have -1 is equal to m into cos of 360 degrees plus n. What is cos 360? Is 1. Therefore, -1 is equal to m into 1 plus n. Therefore, we make n the subject. N is equal to -1 minus m. This is equation 2. Once we are here, we have n being the subject in both of the equations. We can equate the equations from here and solve for m. So we can say 3 plus m is equal to -1 minus m. Therefore, we're going to have 2m is equal to -1 minus 3 divided by 2 on both sides. By 2 on both sides. Therefore, m is equal to -1 minus 3 is -4 divided by 2 is -2. As -2. That is m. And then for n, we can take either of the equation. N is equal to 3 plus m, which is -2. Therefore, n is equal to 3 minus 2 is 1. 3 minus 2 is 1. What is our n? Our n is the vertical shift. The graph has been shifted 1 unit upwards. As you can see here, that the baseline is there at 1. And then the other one, m, is what? M is -2. The amplitude and the sign representing that the function has been reflected. So as we see, the function is facing down, so makes sense. Our answers make sense. Let's go to example number 7. Example number 7. Okay. Okay. So for example number 7, in a diagram below, the graphs of two trigonometric functions are shown. So first thing first, we see the first graph with the asymptotes. We know that this is the tangent graph, and then we have the other graph beginning at 2. It's like this. We can see that is a cosine graph. We have to determine the equations now. The equations. So we're gonna do the same thing we've just done from the previous two examples. From the previous two examples, since we do have coordinates for these graphs. Okay, for these graphs. For number C, what is the general formula for the tangent function? Let's start with the tangent function. Let's just say number 1. In fact, number 1, What is the general formula? The one that we introduced earlier. The general formula for the tangent function is y is equal to a tan x plus q. Okay, and we have coordinates, which means we can solve for a and q. Let's go ahead and do that. Let me write down the coordinates here that we have is 45 degrees and 2, and then the other one is 135 degrees and minus 2 and minus 2. Okay, let's substitute the coordinate. We're gonna have 2 is equal to a into tan 45 degrees plus q. What is tan 45? Tan 45 is 1, so we're gonna have 2 is equal to a into 1 plus q. Then we say make q the subject. Q is equal to 2 minus a. That is equation number 1. Next, let's substitute 135 degrees and negative 2. So we're gonna have negative 2 is equal to a tan of 135 degrees plus q minus 2 is equal to a. What is tan? Tan 135 is negative 1 plus q. Therefore, let's make q the subject. Q is equal to negative 2 plus a. Negative 2 plus a. This being our second equation. Then we equate the two equations. 2a is equal to minus 2 plus a. So we're gonna have 2a is equal to 2 plus 2 divided by 2 on both sides. A is equal to 2 plus 2 is 4 divided by 2 is 2. That is the value of a. Okay, and then from there we can solve for q. We take any equation. Take the first one. Q is equal to 2 minus 2. Therefore, q is equal to 0, which means the function has not been shifted. Up or down. As we can see that the function is in fact not shifted up and down. First thing first. But we were looking for the equation. Therefore, what is the equation? The equation, let's see, it's gonna be y is equal to 2 tan x. Y is equal to 2 tan x. That is the equation for the first function. And then next, let's do the cosine one now. The cosine one, we have 2 points, also negative 2, and this one here at negative 4. This is 0 degrees and negative 2. You have to be able to interpret these drives, guys. Okay, then let's come here. What is the general equation for the cosine function? The general equation is y is equal to a cos x plus q. Y is equal to a cos x plus q. Okay, and then the two coordinates that we have there is what? Is minus 0 degrees and minus 2. Quickly double check. Yes, 0 degrees and minus 2. And then the other one is this one here, 180 degrees and 4. 180 degrees and 4. Okay, and then let's generate our equations. Start by substituting 0 degrees and negative 2. Negative 2 is equal to a cos of 0 plus q. What is cos of 0? Is 1. Therefore, negative 2 is equal to a into 1 plus q, which makes q to be equal to negative 2 minus a. And this is equation 1. Now let's substitute 180 degrees and 4. We're going to have 4 is equal to a cos 180 degrees plus q. What is cos of 180? It's negative 1. So we're going to have 4 is equal to a into negative 1 plus q. Make q the subject. Make q the subject. We're going to have q is equal to 4 plus a. 4 plus a. And that is equation number 2. Equation number 2. You equate the two equations since they are both equal to q. We're going to have negative 2 minus a is equal to 4. Equate equation 1 and 2. Equate equation 1 and 2. We're going to have negative 2 minus a is equal to 4 plus a. And therefore, we're going to have 2a is equal to minus 4 minus 2 minus 4, of which we divide by 2. Therefore, a is equal to negative 6 divided by 2 is negative 3. Is negative 3. Negative 3. Okay, and then next we solve for what? We solve for q. We solve for q. Take any. Q is equal to 4 plus a, which a is negative 3. Therefore, q is going to be 4 minus 3 is 1. 4 minus 3 is 1. Okay, that is the values of a and q. Of which should make our equation to be y is equal to minus 3 cos x plus 1. To minus 3 cos x plus 1. Okay. Then next, we are asked to write down the range, the amplitude, and period of each graph where possible. So for the tangent graph, we know the range. It doesn't have the amplitude. Okay. That it would have been easier. Okay. For number 2, I will just do it like this. For number 2, y is equal to, just so that you know which one we are talking about, the tangent 2 tan x, y is equal to 2 tan x, y is equal to tan x. The range is what? Y is equal to y is the element from negative infinity, it's a tangent function, to positive infinity, and then no amplitude, and then the period is gonna be what? Period is equal to the tangent function. The period is equal to 180 degrees. Period is equal to 180 degrees. And then for the other function, of which is y is equal to negative 3 cos x plus 1. Starts with the range. What is the range for this function? We come here and know that this function, the minimum value is negative 2. The maximum value is 4. So our range is gonna be y is the element from -2 to +4. positive 4. And then our amplitude here, but is positive, so amplitude is gonna be equal to a positive 3 units. And then period, it's a cosine function. Period, I'm gonna say is what? It is equal to 360 degrees. That's the period. Okay, and then from there, I think we have answered everything in this question: amplitude, period, and the range. Okay, so that is how you go about answering such questions, guys. Okay, let's go to another example. Example number 8. Example number 8. Okay, so this one, we'll sketch the graphs and then we interpret them. Sketch the graphs of y is equal to f at x is equal to sine x, and y is equal to g of x is equal to cos x plus 1. For the domain of x is the element of 0 degrees to 360 degrees on the same side of axis, then answer the questions that follow. Okay, we have to sketch the graphs. Let's come here. We need the table. Let's take this one. Copy. Let's take this one here. Let's see. Yeah, we might as well just use the intervals of 45 also. Okay, so what's the first equation? It's y is equal to sine x. So we're gonna have y is equal to sine x, just a basic sine graph, and then the second one, so y is equal to cos x plus 1. Let's find corresponding values. Sine of 0 is 0, and let's use this color. Sine of 0 is 0. Sine 45 is 0.71. Sine 90 is 1. Sine 135 0.71. Sine 180 is 0. Sine 225 is negative 0.71. Sine 270 negative 1. Sine 315 negative 0.71. Sine 360 is 0. Sine 360 is 0. Okay, and then let's go to cosine. Cos of 0 plus 1 is 2. Cos of 45 plus 1 is 1.71. Cos of 90 is 1. 90 plus 1. Cos of 135 0.29. Cos of 180 0. So of 225, 0.29, 270, 270, that's 1, and 315 is 1.71, and then 360 is 2. 360 is 2. Okay, now that we have such, we can sketch. Let me see if we can find some x's, some Cartesian plane that we can use. Let's take this one. Copy. Yeah, paste. Okay, just erase a few things. Let's erase a few things. Clean this up a bit. Yeah, okay, and then here, let me see, 1, 2, let's change the scale on this side, on the y-axis. Let's change the scale. Just gonna go with 1 here and 2, 1 and 2, 1 here, 2, -1 and 2. Okay, these are the y-axis. Let's plot the points. Start with the sine function, where x is 0 degrees, y is 0 at 45, 0.71. Somewhere there at 90 degrees is 1. At 135, 0.71. At 180, is 0. At 225, it's negative 0.71. Somewhere there. At 270, it's negative 1. 315, negative 0.71. 360 is 0. And then from there we draw our curve. And it's like that. That's the first function. Let's draw the other one for cosine of 0. At 0 we have 2. At 45 we have 1.71, somewhere there. At 90 we have 1. At 135, 0.71. Should be here. 0.71. Okay. What am I doing? No. At 135, it's at 0.29, somewhere here. Almost made a mistake. And then at 180, 0.225, 0.29. At 270, it's 1. There. 315, 1.71. There. And 360 is 2. Here. Then we join our points. we join our points. And that is how the function is gonna look. This one is for y is equal to cos x plus 1, or we can just say grx to distinguish. And then the other one is for f at x is equal to sin x. Okay, and then for number 1, for which values of x is f at x equal to g at x, where these two functions are equal? We come to the graphs, you see that here at this point, that is where they intersect, and here. So at x is equal to 90 degrees and x is equal to 180 degrees. So where x is equal to 90 degrees and x is equal to 180 degrees. That is where the functions will be equal. For which values of x is g at x, the function of g traits are equal to f at x, where now it is traits are equal to f at x. We come to our function, so we'll see, we come to our graphs, wherever the function of g at x is above the function of f at x, that means it will be equal. We come from here, the function of g at x is above, then it goes below the function of f at x, and then from 180 degrees, once again it goes above. So for number two, that's where first thing first, that first interval where x is greater or equal to 0, traits are equal to 0 but less or equal to 90 degrees, where x is traits are equal to 0 but less or equal to 90 degrees. That's the first interval. Traits are equal to 0, less than 90 degrees, and then the other one from 180 where x is greater or equal to 180 degrees. That's the second interval. Okay. For which values of x is f at x, the function of f less than or equal to 0, where the function of f is now below the 0 line. It's here. It's that part. Where it's less or equal to 0. So between 180 degrees and 360 degrees, that is our number 3. Let's say where supposed to jump a line at least, and that is where x is straight or equal to 180 degrees but less or equal to 360 degrees. That interval there, that is where f at x is less or equal to 0. And then for which values of x is g at x, greater than 0. So where it's strictly greater than 0, so it's all values of x except 180 degrees. So it's these values here, but once you get to 180, it is now equal to 0, and then once again you go above. So it is all the values of x except x is equal to 180 degrees. That is our number 4. So we can say where x is the element of 0 degrees to 360 degrees, but x can never be equal to 180 degrees. Okay, so it's for all values of x between 0 and 360 degrees, but x cannot be equal to 180 degrees. Okay, and then for which values of x is g at x minus f at x equal to 2. G at x minus f at x equal to 2. Okay, we can see here that g at x is a 2 while f at x is what is 0. So 2 minus 0 is 2, and then we go right up until 2 once again minus 0. So it's where x is equal to 0 and x is equal to 360 degrees. That is number 5, where x is equal to 0 degrees and x is equal to 360 degrees. Okay, for which values of x is f at x multiplied by g at x rates are equal to 0. So I usually like to do this when I encounter the questions of products. So where its rates are equal to 0, it means it can only be rates are equal to 0 when we have positive value. So a negative multiplied by a positive will give us a negative, so it won't work. A negative multiplied by a negative will be rates are equal to 0, so it will be positive, so that will work. Positive multiplied by a positive will give a positive. Okay, so let's come here and look for all those values whereby the product of these two functions is rates are equal to 0. Okay, we start here from x up until from where x is equal to 0. Both the functions are above 0. Both of the functions are above 0. So right up until 180, it will work. This will give us positive, and then once we get to 180, f at x goes below, so it won't work because negative multiplied by a positive is a negative, so it's below 0. But once we get to 360, once again f at x is 0, and then 0 multiply any number, it gives us 0. So it's gonna be where x is greater or equal to 0 but less or equal to 180. This is number 6, and this is number 6. It's where x is greater or equal to 0 but less or equal to 180 degrees, and where x is equal to 360 degrees. Those are the points, and that is how you go about answering those questions, and interpreting the graphs So yeah, that is that for today's lesson. Until we meet again, I wish you guys good luck and good studying.